Hello everyone, so today I'm going to introduce another way of solving problems involving vectors that are not at right angles with each other. So for instance, we have here vector A and then vector B here, and we want to know the resultant vector R. So assume that's the straight line. So this vector R here, the resultant vector, and to get the magnitude and the direction of resultant vector R, we have to use certain rules. But we notice that the angle between A and B, let's call this angle theta. So we notice that this is not 90 degrees, meaning this is not a right triangle. So that means we cannot use the Pythagorean theorem, since we know that Pythagorean theorem is only applicable for right triangles. Now, how do we find the magnitude and the direction of this resultant vector R given this situation or given this problem? So in order to do that, we can use the laws of sines and cosines, which gives us the relationship between the different magnitudes of the sides and the angles. So let's say, for example, we have here a triangle. Let's label this side as A, and then this B, and then C. Now, the angle opposite the side A is called angle A, capital A, and the angle opposite the side B is angle B using capital letter B, and lastly, the angle opposite side C is angle C, so let's use capital C. Now, the relationship between this capital side A and then angle A and then B, then angle B, is given by the sine law, which is the sine of A divided by sine the side B, side A is equal to the sine of B divided by side B, and is also equal to the sine of C, or sine of angle C, divided by side C. Okay, or we can flip this if you want to, or if you need. So which means A, or side A, divided by the sine of angle A is equal to side B divided by sine of angle B, which is also equal to side C divided by sine of angle C. So that means, let's say for example, we are looking for angle C, and we know the angle, this one, the angle opposite to it, which is sine C, and then we know another pair of side and angle, let's say for example A, or we know side A and angle A, so we can just simply equate this to A is equal to sine of A. Then to get C, C is equal to A times sine of C divided by sine of A. So in this way, we can now get the value of C. So next is the law of cosines. Okay, so let's say for example, again if we have here vector A with a magnitude A, and then vector B with a magnitude B, and the angle between vector A and B is theta, then if we want to know the resultant vector C here with a magnitude C, so to get the magnitude of the resultant vector, we can use this equation, the cosine C square is equal to A square plus B square minus 2 times AB cosine of theta. So again, since we're looking for C, the angle here should be the angle opposite the side C, which is cosine theta. And again, to get C, that should be equal to the square root of A square plus B square minus 2AB cosine theta. Now notice that if the angle is equal to 90 degrees, we know that cosine 90 degrees is equal to 0. So if cosine, if the angle here is 90 degrees, this part of the equation will become 0. So therefore, at 90 degrees, c square is equal to a square plus b square. So notice that this equation is the same as the Pythagorean equation or the Pythagorean theorem. So we know that Pythagorean theorem is only applicable for right triangles. Therefore, Pythagorean theorem is just a special case of the law of cosines. And we can use it to get the magnitude of the resultant vector of two vectors that has an angle that is not equal to 90 degrees. So to give you an example, let's solve this sample problem number 1. So the vertical force P of magnitude 100 kilonewtons is applied to the frame shown. So here is the illustration. To solve P into the components that are parallel to the members AB and AC of the frame. So this is our component, or the resultant component, or the vertical force, which is P, and the components of this force that is parallel, or the component of this force which is parallel with AB, is directed towards this direction. So this is PAB. Now the component that is parallel with AC is this. So this is PAC. Now to redraw that, so let's first draw the component that is parallel with AC. So that is PAC. And then next, let's draw PAB from the tip of PAC. Okay, so this is PAB. Now the resultant vector, or the vertical force, we can draw it here from the tail of PAC going to the tip of PAB. So this is P. Okay. Now notice that the angle between PAC and the vertical, the wall, is 35. So this is 35 degrees. And the angle between PAB and the wall is 70 degrees. Therefore, we can say that this is 70 degrees. So we're left with this angle, which is 110 degrees, since 110 and 70 is 180 degrees. And then this gives us the value of this angle as 35 degrees, since 110 plus 35 plus 35 is 180, since we know that the total or the sum of the angles of any triangle is equal to 180. So let's first find the value of PAB. So to find the value of PAB, we can use P. Okay, so this is P, and this angle. So to put that in equation, we can use the sine law, or the law of sine. So that is PAB, and the angle opposite the PAB is 35 degrees. So sine of 35 degrees, which is equal to, again, this value, which is 100 divided by the sine of the angle opposite that side, which is sine 35 degrees. Therefore, PAB is equal to, so let's put it here, so 35, or 100 times sine of 35 divided by sine of 35. So we can cancel this. Therefore, PAB PAB is equal to 100 kilonewtons. Okay, so that's it. So we already know that PAB is equal to 100 kilonewtons. So now let's look for the value of PAC. So what is PAC? To get that, let's use the law of sines again. So that's PAC divided by the angle opposite to it, or the sine of the angle, sine 110 degrees, is equal to, again we can use this two. So this is 35, so P, which is 100 kilonewtons, divided by the sine of 35 degrees. So therefore PAC is equal to 100 kilonewtons times sine 110 degrees divided by the sine of 35 degrees. So this would be equal to 163.8 kilonewtons. So PAC is 136.8 kilonewtons. So those are the values that are or the components of P that are parallel with AB and AC. So another example, the two tugboats apply the forces P and Q to the barge, where P here is 76 kilonewtons and Q is 52 kilonewtons, and we're asked to determine the resultant of P and Q. So the best way to do this is to analyze the direction of P and Q. So notice that the direction of P is going this direction, and then Q is towards this direction. So if you will redraw this, so let's first draw P, vector P, so which is directed towards this direction, and so this is vector P, and then we draw the next vector, which is Q, from the tip of vector P, here, going here. So it's, and then to draw the resultant vector, we draw it from the tail of vector P going to the tip of vector Q here. So this gives us the vector R to move towards this direction, or to point towards this direction. Now we label them. So this is P, Q, and R, and then the angles. This angle, the angle between P and Q is phi. Then the angle between R and the positive x direction is theta. This is alpha, and then the angle between these two is gamma, and the angle between between Q and the horizontal is B, or beta. So by inspection we can get the value of alpha. So alpha is equal to the arctan of, so the components of this, so this is the opposite side is 32, this is 32, and then this is 16, so which means alpha is arctan 32 divided by 16, which is equal to 63.4 degrees. Okay, now we can get now beta. It's arctangent of, okay, now the components of this, so this one is based from this equation, or based on this illustration. So this is 24, and then this is 12. So now therefore the opposite side of this beta is 12, and the adjacent side is 24, which gives us 26.6 degrees. Now, since alpha is the same as this, okay, this whole angle, they are alternate angles, therefore they must be equal. So to get the angle phi, so we can just subtract alpha minus beta. Again, alpha and this whole thing, so beta plus phi is equal to alpha, they are the same. So which gives us the value of phi as 63.4 degrees minus 26.6 degrees is equal to 36.8 degrees. So now here phi is equal to 36.8 degrees. Again, the value of this angle is 36.8 degrees. We tried to find the value of this angle since it's the angle opposite with the resultant vector r. Since we're trying to find this vector, we can now use the cosine law equation, which is c squared is equal to a squared plus b squared minus 2ab cosine theta. Okay, or in this case, we are looking for r squared, which is equal to the sides that are given, or the components, which are p squared. So this is p squared plus q squared minus 2p q times the cosine of the angle opposite this side, which is phi. Okay, so substituting the values, so that is 76 square, so again the square root, plus 52 square, so this is 52 squared, minus 2 times 76 times 52 times the cosine of 36.8 degrees. Therefore, r has the value of, so that's 46.4 kilonewtons. So this is the magnitude of the resultant vector r. Now, using the cosine law, we were able to get the value of r, which is 46.4 kilonewtons. Now, the next thing we have to look for is the value of theta, or the angle, the direction. So to get that, we can use the sine law. Since we're given with the values of phi here, and then the opposite side of the resultant vector 46.4, and then we're also given with other sides, so we can use those values to get the sine of gamma. So sine of gamma divided by the opposite side, or the opposite side with the gamma, the angle gamma is q, which is equal to sine of phi divided by side r. So which gives us sine of gamma divided by the magnitude of q, which is 52, is equal to sine 36.8 degrees divided by the opposite side, which is 46.4. So therefore sine phi, or phi, gamma, sorry, is equal to arc sine, okay, 52 times sine 36.8 degrees divided by 46.4. This gives us 42.2 degrees. 42.2 degrees. So this is gamma. Now, so this is 42.2. Now, but what we're looking for is this. Okay, given that we have the value of alpha, which is 63.4 degrees, and this is 42.2. Now, to get this, so that should be equal to 180 degrees minus this 42.2 minus 63.4. That should be equal to 74.4 degrees. Therefore, theta is equal to 74.4 degrees. Now, the final answer should be R is equal to 46.4 newtons, 74.4 degrees with the horizontal.